my name is Roger Lee with Unforgettable Fire, and this is Shane Clark from Tegpro. Again, we're here in Vermont working on thermoelectric generation because as I travel the country I talk to a lot of people and they are telling me the things that they want to see from us. As most of you probably know, I invented the Kimberly and Katydid wood stoves, and Shane and his group have been helping me by producing our thermoelectric generators. What we want to show you quickly today is that these thermoelectric generators are producing electricity and hot water. This large coil back here of PEX tubing contains, that's 300 feet of PEX tubing, and it contains 4 gallons of water. We can circulate 130 degree water through that entire run. In other words, you can do an in-floor heating system, you can do hydronic heating, you can also run that through the soils of a greenhouse to keep the plant's roots from freezing during the winter, something I was told in Kansas would be much appreciated. So back here, we have these 3 different pumps. We have a 5 watt, a 10 watt, a 15 watt pump. Same over here, another 15 watt pump. What we're seeing right now is that the system is powering not just this pump, but also this LED strip light. You notice, even with the pump and the strip light running, we've still got 10 volts. And Shane's going to tell you what all can be done with that 10 volts.
Well, we actually can generate up to 2 amps of power at around 12, 13 volts. So we can actually charge battery systems at around 2 amps with that system. And that's on top of what we're using to run the pump. In this particular scenario, we're running a 10 watt pump, which is about 2.5 gallons per minute. As Roger was talking about these pumps back here, he was talking about them in terms of power consumption. They are 5, 10, 15 watts, but the big difference is water flow. And this pump's able to push around 2 gallons per minute. This pump's able to push around 2.5 gallons per minute. And the one on the bottom can push around 3 gallons per minute. This pump is actually capable of pushing about 5 feet of head pressure. This one's about 7.5, and this one's about 10 feet of head pressure. So if you wanted to put a wood stove down in your basement, for example, and pump your hot water upstairs to baseboard heating systems, you could easily do that with this pump on the bottom because it can handle 10 feet of lift. So these pumps also work great. We've been using all 3 of them for the scenario with the tubing to push through 300 feet of tubing without the head pressure being very low. It's not an issue with these 3 pumps at this point in time. So it's important to realize that you can get away with a lower power consumption pump for this particular system. Again, we can charge batteries up to 2 amps of power with this particular system we have on the stove now, on top of running a pump.
So you could also then have a wood stove upstairs and pump hot water downstairs to radiators and back up to be reheated.
Yes, absolutely.
That would solve a lot of the questions we get about people wanting a stove down or upstairs where they live, but wanting some auxiliary heat downstairs.
And it's important to realize too that it's not just radiant tube and baseboard heat. You could also use this with radiators, standard radiators, whether they're cast iron or aluminum. Also, you could use them to run through a heat exchanger and a hot water tank. So it's important to realize that those are other opportunities you can utilize the system.
And if I'm correct, we could heat a hot tub this way, couldn't we?
We could.
There we go, folks. Awesome. Keep checking with us. We'll keep you posted. Thank you.